In this episode of Eye Tracking Fundamentals, we will show the ETVision paired with the Vicon Motion Capture System's Nexus and Tracker to combine head motion with gaze. We are using a 4-Vero camera setup from Vicon to track the head position and orientation. We attach the Argus-supplied rigid body to the ETVision wearable eye tracker. Here we show the setup of both the Vicon Nexus and Vicon Tracker with the ETVision application. After launching either Nexus or Tracker, we will load a rigid body file that comes with your ET3Space package. This rigid body, as seen previously, is a collection of reflectors with the origin and axis directions designed to be coaxial with the scene camera of the ETVision optics. Once loaded, we may then move the ETVision with the rigid body about the environment and view its motion in the Vicon Scene Space window. We may now launch the ETVision application and establish communication between the Vicon system and the ETVision. We stream the Vicon 6 degrees of freedom information to ETVision via TCP/IP protocol. In ETVision, we select the motion capture system, in this case Vicon, make sure TCP/IP is selected, verify an IP address of the Vicon system, and choose Connect. Once connected, data is now streaming from the Vicon system to the ETVision application. We may open the ETVision data display window and view the XYZ azimuth, elevation, and roll as reported by the Vicon system in the lower left corner of the data display window. Once positional information from the Vicon to ETVision is established, we may now define scene planes using ET3Space. We enter in the real-world dimensions of the surface we want to define. In this case, we are defining the display to the left, which has the same dimensions of our previously defined display. Once these dimensions are entered, we simply click on the 4 corners of that surface. To make this easier, you can expand the scene image to full screen to make placement of the corners easier. Once we've clicked on all 4 corners, our scene plane is defined. We may adjust the boundaries of that plane if desired by using a simple slider. And once completed, our plane is done. We may repeat this for multiple planes in your environment. We may move the ETVision headset about and see the plane boundary move accurately with the defined surface. This is a one-time setup and will be applied to all data collection sessions. Let's view a data collection session. In this clip, we may see the participant to the left, the ETVision and Vicon application to the upper right, and the gaze shown relative to the workstation in the lower right. If we note the ETVision application, we see gaze is reported relative to the forward-facing scene camera of the ETVision. As the participant's head moves, the content of the scene camera changes as well. Combining the head position and orientation reported by the Vicon system with the gaze relative to the head by the ETVision, we may project a gaze vector in space. Using the previously defined scene planes, we may then calculate and report the intersection of that gaze vector to the scene plane and report gaze relative to that plane in real-world coordinates, in this case centimeters. Data relative to these surfaces is determined in real time and may be streamed out or recorded for later analysis in the Argus Science ET analysis package. Here we see 4 different views of the same data collection. In the top view, we see the ETVision scene camera with gaze shown relative to the scene camera. On this same view, we see the 3 displays tracked with bounding boxes as the head moves relative to the environment. The 3 lower videos represent the ET3Space data presented over an image of the workstation. Areas of interest are attached to this image, and data is easily reported and visualized as fixation, gaze points, or heat maps. Statistics such as time in area, fixations in area, time to first fixation, and many more statistical metrics are quickly and easily assessed using ET3Space for any participant or group of participants. Thanks for watching. For more information on the Vicon 3D Motion Capture System, please visit www.vicon.com. For more information or any other questions, please contact Argus Science at www.argusscience.com.